Good afternoon. This is Ravi Babu, Assistant Professor in EEE Department. Today, I am going to explaining about the digital control system. In this one, I am going to the first model is sampling and reconstruction. Sample and reconstruction. So, in the digital control system, we are going to first of all studying about the schematic diagram of digital control system and its limitations, advantages. After that one, we are going to moving to the analytical structure of digital control system. That is, in case of the analytical structure of digital control system, we are going to considering the every block in the block diagram of digital control system and its operation. And the concepts of sampling and reconstruction also we are seeing in the first module. Now, after that one, in case of the second module, we are going to seeing the finishing of this digital control system block diagrams, schematic diagrams. We are going to analyzing the jet transform. Okay, so we are taking a review of the jet transform and its properties, and also inverse jet transform also we are going to taking and applications of jet transform into differential equation, pulse transfer function, first transfer function for computational realization, and finally we go for the two-stage stability tests in digital control system, that is Ackermann's formula stability and Ravi stability criteria. After that one, in last module, we are going to move to the design process in S-plane and W-plane, where in the different type of control cells, that is lag lead, and lead lag components and PID controllers. After that one, we are going to moving the jury stability tests in the last module. So now I am going to taking the coming for the digital control system topic. Before going to digital control system, now I am taking the example of the linear control system. In that one, I am taking the feedback, that is closed loop control system. Okay, so it is also called as a conventional control system and classical control system. I am explaining this one with brief discussion. Why? Because it is applicable for in case of the digital control system also. So where here generally we are in the any system. Okay, generally we are in any system. In the system is nothing but here I am taking a plant. Any system here I am taking as a plant. Okay, for that plant, if you want to getting the output, so you have to give the some commands from the input. From the input, we are going to give the commands. So what I am saying is here plant will be there. For plant, if you give the supply some commands, input commands, it is give the output. That is nothing but if you are giving the exact input to equations, okay, that is any equations, mathematical equations or programming, okay, algorithms, anything. If you are getting exact output, so there is no problem. If exact output is not coming, nothing but we are going to changing the again input values. So that input data is going to be given to again plant or process system. So we get the output value. So this type of system is called as a open loop control system. That is nothing but there is no feedback in case of the open loop control system. Okay. So every time we are going to changing the input section side for getting the exact output section. Okay. Here also for this plant, we are in the controller. From this control parameters, we are going to be control the plant parameters. That is nothing but what is the control system? Control system is nothing but it will be control the plant parameters or process parameters or system parameters, and also controls the controller parameters, that is itself parameters, and regulate the total system also. Why? Because at the time after the plant or before the plant, okay, you are getting any type of disturbances, okay, errors, the disturbance and thing, but it is going to be affect the plant output. That's why the control parameters is going to be regulate the total system parameters also. Okay, total external and internal system parameters also. So it is in case of the open loop control system. Coming for the closed loop control system. In case of the closed loop control system, same process is there. That is, there is a system. For system or plant, we have the controller. So from controller, we are giving some input data to plant. This controller is going to be connected to the input command and some element, that is this one. What is this value? Some element. What is this one? For example, if you are not getting exact output here, output section inside, so if you give any input to the controller, from the controller, plant is there, from the plant we are getting the output. But if you are not getting the exact output, take this output value in backside, feedback, sensor. Okay, take this value in feedback form. That is nothing but with the sensor. This is going to be sense the values, and it will give into the input section side. That is, if you getting here after the plant, if you getting output is more. For example, I am taking with integer values. So, for example, if you want to output is 20 megawatts power, okay, but you are getting here 15 megawatts power. Okay, so what happened? The desired output is not coming. So I am taking this 15 megawatts power into with feedback sensor with feedback. Okay, here. Okay, now. So what is the input of this one? The input of this one is, if I am giving the input is 5 megawatts. Okay, 5 voltages, 5 volts. Otherwise, 5 volts. Okay, 5 volts I am given to the input section side. So what happened? It is not reached to your target. So I am taking the feedback. So this feedback is negative feedback is coming here. So it is compared with the input signal and given the error signal to this one. Okay. So again it is going to be given to the modified signal to the plant. At the time it is increased. Why? Because we are taking the feedback of this one in previous section. So it is increased to 16 or 17 like this. Up to we have to go to this one up to 20 megawatts power supply. Okay. So this is the closed loop control system. Okay. So this is your closed loop control system. Now I am going to move into the topic is digital control system. Okay, digital control system. When I am going to move into the digital control system here, I am taking in case of the digital control system, we have to analyze the first of all, it is which type of inputs will be there. Okay, generally we are in case of the digital part, we have to analyze the first of all, what is the analog signal, what is the digital signal, what is the continuous time, what is the discrete time. You have to analyze that one. So for that one, taking data. If I am taking continuous time analog signal. That is nothing but time is going to be continuously, and it is an analog signal. Analog nothing but continuous signal. Okay. So if you take like this also, otherwise sinusoidal waveform, anything. If you take step, okay, step like this, ramp, parabolic, impulse. Okay, that is already we are having the 4 type of the test signals is there. That is step, ramp, parabolic, impulse. Okay, so these are the continuous time signals. So this is the continuous time analog signal. Okay, here x of t is the input. Okay, current or voltage or power, anything. Okay, it is continuously, the graph is like this showing. That is, it is continuously time analog signal. Okay, continuous time, it is continuous time. Here also time same, continuously going time. Okay, analog signal. Okay, coming for the next one. What is the next one? That is your, so I am taking first one is continuous time analog signal is completed. Okay, it is first one. Next one is continuous time digital signal is also existing. Continuous time digital signal is also existing. That is, see the graph. Here, it is the time is continuous and it is digital form. That is nothing but at this portion, okay, at this one, highest value. After that one, continuous. It is maintaining the continuous highest value. After that, it is falling and it is zero value here. Okay, so it is, for example, if you take, it is 1 year, highest value is 1 volt, and if you take it is 1 volt, okay, this value is one, highest value, high value, that is nothing but 1. Here, off position, 0. That is, we compare this one is 6. Okay, on and off positions. If you take it on is nothing but 1, off position nothing but 0. Similarly, so it is continuous time and digital signal. Okay, for every cycle it is going to be off and on off position. So it is your second one, continuous time digital signal. Continuous time digital signal. Now coming for the third one, that is discrete time analog signal. This one, third. And the fourth one is discrete time digital signal. So we are this is the type of the analog and digital time control inputs. Okay, control inputs. So coming for next one, that is discrete time analog signal. Discrete time analog signal. Continue that one. So here, see the diagram waveform. Discrete time analog signal, and the next one is discrete time digital signal. Here, discrete time analog signal, the magnitude is making the constant, same value, and it is on-off position will be there. At the time of sleep position, on sampling will be there, highest value. After that one, it is again 0. I again some value, again 0. Some value 0, some value 0, like this. Similarly for here, for discrete time digital control signal, here also same. What happened? Here, some voltage. Here, voltage is increasing. Again, it is some value, like this. That is nothing but discrete time. It is time is discrete nature. Here also time is in discrete nature. But here, it is the analog. Continuous will be there. Analog nothing but continuous. Digital nothing but on-off positions here. On-off position. Okay. These are the type of signals and timing. With timing. Okay. So, all of understand? So, we are having the 4 types. Continuous time analog signal, continuous time digital signal, discrete time analog signal, discrete time digital signal. We are in the 4 types. Now, coming for the introduction of the and block diagram of the digital control system. Where, in case of the linear control system, we are having the only, here, I am drawing the linear control system block diagram. Linear control system closed loop diagram I am drawing. It is system. Okay. For system, we are getting the output. For system input is one controller is there. Controller is there. For this controller, input command is there. But I am taking the closed loop now. If you are not getting exact values, take the feedback. That is the thing. But in here I am mentioning measuring system. It is also same as measuring system of feedback. Feedback. Okay. This is given. And here error signal is there. If you want a negative feedback, here make it minus. It is reference input R of T. It is output is C of T. It is error. It is positive value. It is negative value. And error is E of T. This is your general linear type closed loop control system. Now I am going to this one is the digital control system. That is nothing but your system is same. Okay. Feedback is same. Okay. Only at the part of the controller we have the digital computer and analog to digital converter and digital to analog converter. Digital to analog converter. Okay. This is your block diagram. that is nothing but we are replacing only controller block is with one digital computer and analog to digital converter and digital to analog converter. That is, in case of the block diagram digital control system, we having the two controller parameters. That is your ADC and DAC. ADC and DAC. Okay, ADC and DAC. Now, I am going to, what is the functional operation for this one? I am going to, coming for here. Okay. Generally, what is the system? System is a one plant or processor. For the system, which type of signal is coming? Input signal is, how many input signals is step signals? Input signal, step ramp parabolic, no? So I am taking analog signal here. For the system, analog signal is coming. Okay, that signal is coming to the system, we are getting the analog output. Analog output. This analog output is going to be feedback. Okay, it's now okay. I am using digital control system now. I am using digital control system. Here, in case of the digital control system, that is controller block. In case of the digital controller block, I am using digital control system. In case of the controller block, I am using digital control. Digital controller is here computer. Here computer. Okay. Compare this one into linear control system. In case of the linear control system, system is controlled with controller. Whereas in case of digital control system, the system is controlled with control parameter. That control parameter is a digital control system parameter. Digital controller is a computer. Okay, that parameter is a computer. So, the computer, coming for the computer, the input is, which type of input? Digital form. And the output is also digital. That's why here we are using two types of controllers. Okay, two types of controllers for controller block. One is DAC and one is ADC. That is, ADC will be going to be convert the feedback analog signal into the digital form. ADC is going to be convert the feedback analog signal into the digital form. Okay, feedback analog signal into the digital form. The digital form is going to be given to the again to the computer for getting exact output at output section side. Okay, so the digital output of ADC is going to be applied to the again digital computer. Okay, so digital computer is giving, in the digital computer we are in the algorithm, some algorithm values, algorithm programming. Okay, that will be run for these values. Okay, previously only at the time of the starting only reference input is there. Okay, if you are not getting exact output, I am taking the feedback. So that is nothing but from feedback again we are in the sum of the digital value. The digital value is going to be adding to the input of the system, that is computer. So voltage digital value, input value, and coming for feedback input value. So the digital computer is going to be operate with the different parameters of the algorithms. Okay, changing the parameters of the algorithm. So the digital value, the digital output of the digital computer is digital value. Again, the digital value will be going to be applied to the digital to analog converter. Why? Because the DAC output is analog signal. Okay, again the digital value is converted into the digital analog converter. Given to the digital analog converter. The digital analog converter is again going to be converted into analog signal. Why? Our plant is always taking the analog signals only. Okay, so this is the way we are going to operating. Coming for here, one more thing is, it is serial notations here. Okay, for digital control system, the input is R of T. Okay, that is nothing but it is R of K, otherwise T. Why? Because K is I am taking the integers. Okay, 1, 2, 3 like. Why? Because digital computer input will be take the only zeros and ones only. That's why it is R of K or R of T. The output of this one is V of K. Digital form is nothing but I am taking the notation with K. Okay. After that one, From DAC to DAC, it is coming to as analog form. For analog form, I am taking the TE. Analog form, I am taking the TE. It is our output. Again, output is measured. That measurement output is will be taking the V of T. Okay, Y of T. That one is converted into digital. Again, here analog. It is analog. It is digital. It is again analog. It is again digital. Okay. In this way, the block diagram of the schematic diagram, in this way the operation is going to be getting. Okay. Now I am going to next one. That is main action of the heart of the system is computer. Okay. What happened to the computer? Please see. What is that one? You have to find the determine the error E of T. So what is the E of T? E of K here. E of K nothing but this one. This is here coming E of K. E of K equal to Y of K. See, R of T minus Y of K. This is R of T. It is Y of K. They are taking minus. Nothing. It is a negative feedback. It is a negative feedback. So here and determine the error, that is E of K equal to R of T minus Y of K. R of T minus Y of K. Okay. Why I am taking the minus is it is a negative feedback. Okay. Next, apply this E of K. Apply this E of K to computer. Just here summing point is there. Just only simple. Make it reference input R of T here. Y of K. It is E of T. Y of K. R of T minus Y of T. That is given to the input section side. Next. E of K is going to be given the control algorithm to generate the E of K. Next. What is the next one is? Factors affecting the performance of digital control system. That is, when you are using the digital control system, the accuracy of the measurement is going to be maintained. Okay. And the resolution of the ADC and DAC. And the speed of the computer is also will be perform the digital control system. Okay. Accuracy. So next one is control algorithm. Okay. If you write the control algorithm very perfectly, if you get the digital control system is very fastly accurate system. Okay. Next. I am going to closing this one today. Thank you. Okay. Now I am going to closing this one. Okay. In next class, we will see the advantages, performance of the digital control system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.